So welcome to the official office hour, which is the fifth in our five-part series, the last one in the mixed action, or in the advanced action levels office hour series rather. And this topic today is the mixed action levels. As I said, my name is Liz Herman, and I am a trainer and programs analyst with Earthsoft. So the agenda for today is going to be very similar to the agenda that we had last week when we were talking about just formulas. So we'll review an example of a mixed calculated action level in situ, basically how it comes from the governing body. Then we'll take a look at some of the available formulas and then the lookups as well. And then we'll talk about how to configure the example action level that we have. So the actual action level that we're going to be working with today is from the Canadian Council of Ministers of the Environment, Copper Canadian Water Quality Guidelines. I'll probably call this the CWQG from now on. It's a little bit shorter, right? And so you can see that it's sort of written out here as a word problem. And I retrieved this screenshot directly from the website that's cited at the bottom of this slide. And you can see that it's essentially saying that the copper action level is related to the hardness values. And so when hardness is 0 to 82 milligrams per liter, then the CWQG copper action level will be 2 micrograms per liter. Then that changes to a calculated action level if the hardness is between 82 and 180 milligrams per liter, inclusive. And then when hardness is greater than 180 milligrams per liter, then the copper action level is going to be 4 micrograms per liter. And then finally, the last point, if you don't have hardness data, then you default to the action level of 2 micrograms per liter. Okay, so this is their vocabulary pulled straight from the website. So let's break it down a bit into EQuiS speak. So I have these guys basically the same information bulleted out. So the first one of this bullet is a lookup, because it's essentially saying if it's null, then it's 2. Okay, if hardness is unknown, then the action level will be 2 micrograms per liter. The second and third are also lookups, because it's saying when the hardness is in range of 0 to less than 82, it's also going to be 2 micrograms per liter. And then the final one in that list, if hardness is greater than 180 milligrams per liter, then the action level is going to be 4 micrograms per liter. And then there's that guy in the middle, and that is going to be our calculated action level. That's essentially telling us that if it's in that inclusive range of 82 to 180 milligrams per liter in our hardness values, that we're actually going to use any of those values of hardness to help calculate what that action level is going to be. And in fact, they even give us this handy equation right here so that we can calculate it for ourselves. Even better, this particular website has a little hardness calculator that's available right there. So once we think we figured it out, we can actually go back to that website, put in some actual data, and see if the value that's returned is what EQuiS thinks the action level should be as well. Okay. So in terms of the calculations that we're going to be talking about today, I'm really going to focus mostly on the single mixed, though I will give a brief example of the multiple mixed at the end of the session. I'm sort of presupposing that you got a little bit of information from the single formula session from last week, but I will talk through my logic of picking the formulas and all of that just like I did last week. But so for now, we're looking at a single mixed action level because there's only one contingent analyte, and that's hardness. And then we have both a lookup, which is going to be those ranges of values, as well as the calculation, which is going to determine what the action level is between 82 and 180 milligrams per liter for hardness. Okay, so the next step then is to take a look at our available formulas for our advanced action levels. And there are 8, and they kind of run the gamut of all of the possible calculations. If you think that there's one that's not represented here, by all means, please let us know. We're happy to add additional action level formulas if they come into play in your work. But much of what you potentially could use is already included here. There might be a couple extra variables that you don't think you need. That's okay. Those can generally be shaded out or excluded, essentially using either ones or zeros, depending on what you're trying to calculate, whether that's addition or multiplication there. Okay. So let's take a look at our actual action level and see how that might work here. Well, it looks like I've given up the hint here that we're going to go ahead and already select the calculation exponent log. And I can tell what that formula is the correct, but let's go through my logic for how I got there. So I said the formula needs to have an exponent function first. So that excludes those first three in the list. And then I said the formula needs to have a single natural log function. So that excludes the last four in the list, because those last four in that list either have a log base 10 or maybe two circumstances where we've got a log and exponent, but they're not, in the right spot, or a couple of different logs or what have you. And so just looking at those, I was able to exclude that and come up with the final choice of the calc exp log as my calculation method. And so you can see it's almost exactly comparative. Let me see if I can get my pointer out to help point this out a little bit better. But we've almost have apples to apples here, because we have our value times the exponent, and then the rest of the function here, raise that power with the natural log and our comparison value and all of that. Okay, but in case that's a little bit difficult to see, I've got it laid out a slightly different way. Because the next thing, once we do figure out what our particular calculation is going to be, is we have to plug in the constants. So since I picked out my calc exp log as my particular formula, I know I don't need the a. That's too many variables. Okay, so for the a, I said my constant is going to be 0. For the b variable, that's going to be 0.2. Then the c variable is 0.8545. And then, of course, my comparison value here for the natural log of hardness is listed right there, exactly the same. And then finally, my last value here for my final d constant is going to be 1.465. And in fact, I lucked out, because the example calculation as well as the calculation for our calc exp log is subtract variable d. So I don't have to worry about including a negative number. Although some of the other formulas you might have to fiddle around with negative numbers if it's an addition or a subtraction different than the particular formula. Okay, so that, I think, is relatively straightforward. That was pretty easy, at least, to figure out what that formula is going to be, at least more so than some of the other examples that I've seen. So the next thing that we do once we figured out what the formula is we take the rest of the things that we know. We know that we're going to have some lookup stuff that we're going to have to put in there. We know that we've got some calculation things that we're going to have to put in there. So let's talk about what the there is. How are we going to get this into EQuIS? And that is using, in this case, we're actually going to use the action levels.xsd format. And that plugs directly into the DT action level lookup table. Okay. So if you've been following along with the other advanced action level sessions in the series, you'll know that this is the preferred method to use the EDD format, because it has some checks to make sure that you haven't fiddled around and messed up some logic there. And additionally, it allows you to not have to generate EQuIS yourself in the table as you're trying to manually populate it. So when you're looking at something, even if it's just 4 records that you're trying to add to the DT action level lookup table, it's way easier to use the EDD format than it is to add it manually in the table. Because one of the, I think maybe one of the primary keys rather for the DT action level lookup table is the EQuIS column. Okay. So in looking at the DT action level lookup table, we're sort of going to march down it and talk through the different choices here. So the first thing that we're looking at on the furthest left extent of this EDD table is the lookup source, the lookup code, and lookup method. And those guys are really important because they essentially inform EQuIS that, hi, this DT action level lookup table is related to my other action level tables that are part of just the standard action level sets. Okay, so I'm looking at this and I see lookup source, in this case, is advanced, and that is the exact same value as I have for my action level type that this entire bundle of action levels belongs to. My lookup code is then my action level code, which in this case is the CWQG. And then finally, my lookup method in this case is going to be single mixed. This is the data that is going to be requiring both some lookups as well as some calculations related to them. Okay, and it's in this case going to shift the action level that's applied based on the data that for hardness for any given sample. Okay. So the last two things to point out here are the copper CAS number, which is what we're setting up our action level for. That's what that CAS number field is for. It's a flag me for Y, if you will, column. And then the comparison ID is going to be the CAS number for whatever your contingent analyte is. So in the case of the example that we're talking about today, our contingent analyte is hardness. Okay, that's the first part of the table. Let's march down the next step. So now we're looking at the, still looking at the lookup method, because remember, we're looking, that informs how the action level logic is going to be applied, but so it's single mixed. The next thing to consider is the CAS number, which is going to be our copper CAS number again. And then we've got our comparison ID. It looks like my arrows got messed up a little bit here. And hardness is our comparison analyte. Next are comparison operators that informs EQuIS of how we're actually going to apply that particular function in terms of how the action level is applied. So in that comparison operator, you can see that I have a null value, I have a less than value, I have a greater than value, and then calc. You might say, Liz, there's a whole section of logic that you left out in that, you know, equal to or greater than 82 and less than or equal to 180. What's the story with that? We'll talk about that in terms of order of operations in a second. Okay, so that first value there in the table is saying, what if hardness data is not available? What action levels should I use? And so it says, oh, if there's no data available for hardness, then copper action level should be 2 micrograms per liter. That's what that first section is saying. Okay. The next block that we've got in there is telling me if the hardness is unknown, or that was the first line, if the hardness is unknown. And then if the water hardness is 0 to 82, the CWQG is 2 micrograms per liter. And then finally, if the hardness is greater than 100 milligrams per liter, then the CWQG is 4 micrograms per liter. So our copper action levels are either going to be 2 or 4, depending on where the value falls outside of that range. But that last bit of the range that we haven't defined, that in-between space between 82 and 180, that gets captured by calculation. And that's what's really important. The calc row has to be the last row entered in the action level order of operations. And it's really important to make sure that you put the order in a logic that makes sense, I guess, to EQuIS, because what EQuIS will do when it is going through the process of an advanced action level is it says, hey, I'm going to look at this first line for this single mixed action level for copper. I have data, so I can skip this line. We're good with that. Is my value less than 82? No. Nope, I can keep going. Is my value greater than 180? No. No, I can keep going. And then it'll finally get to that fourth record and say, oh, my data is somewhere between 82 and 180. I know how to apply that action level. It needs to be calculated. Okay. So how does it calculate that? That comes in the next step. So it's going to calculate the action level based on the comparison ID of hardness still, using that formula that we figured out earlier. And we're going to be saying, okay, we're using the calc x log calc method, because we figured out that's exactly the right one for this particular example. We also noted that our comparison operator for that last section, or the everything else bucket, if you will, in terms of the logic steps that EQuIS goes through, is calc. So that says, hey, you have to calculate my action level. I don't know what it is until you've done some math. And then we say, okay, here are what our variables are. And those variables are going to be just how we defined them previously. 0 for the first constant, because we don't have anything representing the variable A. B will be 0.2, constant 3 is 0.8545, and constant 4 is 1.465. Constant 5 doesn't apply to this particular formula. There's only 4 constants, so you just leave it blank. And once more, that calc row has to be the last row for the order of operations for action level. Okay? So, knowing that, let's take a look at what the EDDs look like. We're going to step through this whole EDD first. So in this example, we're looking at my action level code, which is CWQG, and my action level type, which is advanced. This is in the action level table in the action level.xsd EDD. Okay, so I at least have to define my action level code and my action level type. I'm not going to define any matrix because I want it to apply to basically any water matrix potentially, period. So I went ahead and left that blank because if I specifically define it as either surface water or groundwater, it would exclude the other. Okay. And then I did put a remark in the remark field saying that it's a single mixed action level. That was just for my information. That part's not totally necessary. But the last thing that's incredibly crucial is the object name field. And the object name field is populated with the action level library DLLs, which essentially says it's the first cue to EQuIS saying, hey, there's an advanced action level here. You need to dive deeper in the action level tables. Okay, so when it's going through and running the action level exceedance report, if it sees that object name field populated with those DLLs, it says, oh, I have more to do than just a regular action level. Okay. So this first table doesn't have a lot that you have to define, really. Just those 3 fields are required. The next table has a little bit more to it, and that's, of course, the action level parameter table. So under the action level parameter table, you can see that I've still got my action level code as CWQG populated there. And I've defined my parameter code with the CAS number for copper. I was being funny, and I made my exceedance flag for this, CU exclamation point, but of course it could be anything. All right. And then I haven't defined anything for action levels or warning levels or anything else like that along this entire table until I scroll all the way to the right. And you can see that I have finally set my lookup source, my lookup code, and my lookup method. Now remember, the lookup source is going to be the action level type. So in this case, it's my advanced. My lookup code is going to be the action level code, so CWQG. And then my lookup method is informing EQuIS, here's the logic you're going to have to follow once you get into that next table. So it's a single mixed, saying there's going to be some lookups and there's going to be some calculations that you have to apply. Okay, so that's well and good. Let's see what is in our next table, which is the guts of our advanced action levels. So in this table, again, we have our lookup source, lookup code, lookup method, and those are all going to be the same for every single one of these records, because that's what ties this table back to the action level parameter table, to the lookup table. Okay. Again, we have our CAS number for our target analyte, which is going to be copper, and that's going to be the same all the way along. And we have our comparison ID, which is going to be the CAS number for hardness. And then we have our operators and values for each of the possible circumstances. So if no copper is available, or sorry, if no hardness data is available, then our copper action level is 2. If our hardness is less than 82 milligrams per liter, then our action level is still 2. If our hardness data is greater than 180 milligrams per liter, then our action level is 4. And then the else statement, the everything else, then we would calculate our copper action level based on a hardness value somewhere between 82 to 180 inclusive. And the way we would calculate that is with our calc_exp_log method, and then define each of those specific constants as it pertains to that particular example. So if I haul this guy over so that we can look at it on screen, you can see in words what this particular EDD is defining, okay? And there's that lovely action level calculation formula, okay? So once I've got this all set up, I would, open up EDP, I'd pull up the action levels.xsd EDD format, I'd load this EDD, I'd create commit, and then it would be available to me in my database to apply to all kinds of data, Okay, so let's see what that looks like. I happen to have my action level, or my analytical results rather. First, I wanted to pull up just my copper and hardness data so I could see it compared. In this particular example, I happen to have both total and dissolved copper, but hardness is only reported on a total basis in this particular data set. Okay. This is going to apply to both sets of data, however, for both total and dissolved in this particular example. And so what we're going to look at here is, let's take a look at this hardness value of 143. That's somewhere between 82 and 180. So I'd like to see how we would actually see that action level calculated in terms of that quick checker I was telling you about earlier. So I happen to have in sidebar over here my summary table. Remember, I promised there was a nice little calculator. So I said that my value that I want to check is 143 for hardness, and that's in milligrams per liter. I don't have units there. I probably should have added that. But in the example that I have on screen, copper is in micrograms per liter, and hardness is in milligrams per liter. Okay. So if I put in my water hardness here of 143, then it tells me with this handy dandy calculator that my calculated copper guidance should be 3.21 micrograms per liter. So cool. All right, we can figure that out. So let's see how that worked. If I come over to my action level exceedance by user report, I went ahead and selected all of the necessary all the necessary parameters in my user report. And the very important thing to note with this is you have to include all of your contingent analytes as well as the analyte that you wish to be applying the action level for. So in this particular example, I just said, give me all my hardness data and all my copper data for these particular locations. Okay, because I need to make sure I have hardness there. Otherwise, everything is going to come back with an action level of 2. That data might be in the database, but if I forget to include it in my query, it doesn't matter. It doesn't calculate it based on information that's not included in the report. Okay. So I went ahead and selected my appropriate parameters in that particular saved user report, and then I selected my action level, which is the CWQG report, and then I ran it. And I can see here that we've got lots of different instances where the action level was calculated. In some cases, it was applicable. In other cases, it wasn't. So we're sort of on the cusp of having a copper issue maybe in this particular data set. But if we want to look at this a little bit more clearly, I also went ahead and cross-tabbed the data. And so when I set up the crosstab for this particular data set, I grouped it by the individual analytes so that we can see it more clearly with the dissolved and the total copper as well as the hardness values. Okay, so here at the very top of our list is that 143 milligrams per liter for hardness. And if you remember, that suggested calculated value was 3.21. And that's what we're looking at here, 3.21, and it sort of goes on a lot longer because we have more significant digits in this particular calculated action level than it did on the calculator on the website. But it looks like it worked swimmingly. So in this case, our dissolved action level and our total action level are going to be the same because they're determined from the same hardness value. And the dissolved quantity of copper came in underneath, and the total is screaming high comparatively. Okay. But we can see that it went through and did all of that calculation for us without having to worry about it. In fact, if I come down and look at this next result here, I have a hardness value of 182, which puts it over the 180 threshold. And we have an automatic action level of 4. And so it didn't exceed for our dissolve value, but it did definitely exceed for our total value. We can scroll down and see if we had any instances of less than 80. It looks like not. This is relatively hard water, it looks like. So we were either needing to calculate the action level or just apply an action level of 4. But you can see that sort of shake out in each of these examples. Now, if you're uncertain when you're going through and setting these calculations up and you want to do a quick double check, in the materials or the handouts rather of GoToWebinar, there is a copy of this action level or advanced action level lookup formulas with Excel equations. And this particular example, I went ahead and populated with my CAS number for copper and my comparison ID for hardness. This is not a real EDD. This is most definitely just for reference. If you tried to load this, it would go all kinds of backwards and crazy, particularly because the action level field for a calculated action level should be null. But so in terms of the example we were looking at, we were to select the Calc Exp quad. And if I pull up that handy example here once more, let me turn it on so that it's, there we go, so that it stays in front here. I can go ahead and plug in my constants. So remember that my constant 1 was 0 because the a variable was unnecessary in our particular equation. But our next constant is going to be 0.2, and then the next will be 0.8545. Oops. And then final constant is 1.465. And it's always good to double check your calculation, your source calculation, to make sure that that is the right value. And there's a subtraction for that last variable, so that is correct, and rather than adding a negative number. So I've got all of my constants plugged in here. If I want to pick on that 143 hardness value that we were looking at in that report earlier, if I type in 143, bada bing, it does the calculation, and our action level for the calc exp log rather would be 3.2, and then on and on. Okay, so I'm able to sort of double check myself lots of places. This particular example had the handy website calculator, and I recognize that that doesn't necessarily happen all the time, but we do at least have this as an interesting, additional checker for us. Okay, so that pretty much brings us back to the slide deck, because that takes us through to the end of our single information. Oh, I did want to show you one other example. This is actually in our, also in the materials or handouts pane. You certainly don't need to refer to this if you don't want to, but this is another example EDD where there is a comment row for each of the records that you have to populate and why. So if that's easier for you to follow along and say, oh, I need to make sure that I populate this because of this reason, and it explains it out in words, that might be a handy way to sort of think through your first word problem. Okay. So like I said, back to the slides. I see there's some good questions in the questions pane. Well, I promise I'll get there. Okay, so the next part then to talk about is the multiple mixed action levels here. And in terms of the multiple mixed, we're not going to get quite as in-depth with this example as I did with the CWQG example for copper, just because I think that much of the information that's in this particular example is already sort of informed by that first thought process that we went through to get the single mixed established. Additionally, this particular example is available in the online documentation, so if you want to come back and revisit it later, you certainly can. So with this example, it's important to remember that with the multiple mixed action level, the same rules will apply in terms of the ordering and everything else like that. Plus, you have to make sure that you have added a comparison group set of information in order to group the logic together. Okay, and if you need a refresher on that, Sue did a really great office hour presentation on that a couple of weeks ago, and I'll include the link to that in the final part of this slide deck. But you can see that this particular comparison group, or in these individual comparison groups, they're basically chunking together the sets of logic so that EQuIS knows how to step through that ordered logic path. The other thing to remember with the multiple mixed, it can either be an inclusive or an exclusive selection. So this particular example is multiple or, so it's going to be exclusive. Did I get that backwards? Yeah. Okay, but anyhow, the lookup method in this case is going to say if either of these circumstances match, then we're going to apply this particular action level. So let's talk through this particular example a little bit differently. So I've noted out each of the individual comparison groups here and spelled out in words what they're essentially trying to define. So our comparison group 0 here is essentially saying this is what your action level is going to be for cadmium in this case, because that's the cadmium CAS number. If you don't have it, just like that's what your action level is going to be if you don't have additional data. Okay, so that's your lookup. Then the comparison group 1 is stating if your hardness value is less than 17, then your action level will be 0.04. Okay. So if EQuIS is diving through some data tables and is looking at total hardness and it's not less than 17, then it'll step on to comparison group 2. And it'll say, okay, is my hardness value less than 50? If it's less than 50, then it says, hey, I know, I'll apply the cadmium action level of 0.9. Now you'll notice that in this case, between comparison group 1 and comparison group 2, the order definitely matters. If I had put the information that's in comparison group 1 before the other, so if I was saying, hey, if anything is less than 50, then my action level will be 0.9, then it's never going to consider this other action level for the comparison group 1. So you need, essentially, when you're setting these up, particularly with multiple mixed, you need to consider sort of stepping up in terms of the concentration value. So you're not excluding some group by including a value that's greater than the next level up. Okay. Then comparison group 3 is saying that if hardness or total hardness is greater than or equal to 280, then the cadmium action level is going to be 0.37. And then again, if you look at the way that this is set up, there's some space in the in-betweens, somewhere between 50 and 280, that we're going to be calculating our action level. And EQuIS knows to look at the between 50 and 280 value, because that's basically the leftover stuff. And since, again, calculation has to be the very last component in that logic path, it's important to make sure that you you've got your orders logically laid out, and that the last group is the else statement, basically, for your calculation. Okay. So I know that that second component, I sort of blew through it, and I apologize. And I'm happy to go through and talk about it a little bit more, or maybe describe it slightly differently. I can show you an example if you'd like, but I can see that there are some questions in the question pane as well. So this is essentially, as I said before, the 5th in our 5-part advanced action level office hour series. It is introduced and then sort of slowly builds. So if this is the first time you've had a chance to see all of this information, I suggest you go back and watch some of the other videos, because it's sort of, practicing it and letting it sort of gel and set in your mind, and how that works out. So one other thing that I want to point out is that there is some really good online documentation regarding the advanced action levels, particularly for the ones I talked about today. I selected the using formulas in DT action level lookup table that includes basically all of the formula stuff, whether that's the single mixed or the multiple mixed, as well as some previous office hour recordings that might be really handy. The part 3 action level lookups is what Sue described, and she has a slightly different way of describing that, so it might be a little bit clearer than the way that I tried to describe it today. And then part 4, which was last week's, which is just the basics of the advanced action level formulas. All right, so I'm watching questions come in hard and fast here, so let's go ahead and take a look at what some of these questions are. David asks, how are hardness concentrations found? Matching the cis sample code for the copper sample? I believe that's the case. Jim, can you answer that more definitively?
Yes, that's exactly how they're found. So it's this action level can be thought of as a sample-specific action level. It's calculated separately for each sample.
Excellent, thank you. Allison asks, if EQuIS goes through each line, why does it matter putting the calculation as the last? Won't EQuIS stop at the calc value of hardness between 82 to 180?
Well, there's a couple ways to set this up. So one way would be for the order not to matter, but for a less than value and a greater than value be required. But the constraints in the agency guidance don't always have a less than and greater than value. And so the order is how, you say, won't EQuIS stop at the value if hardness is between 82 and 180? I mean, it doesn't know what the hardness value is less than or greater than until it steps through those steps. And because we make order matter, then nothing is required in the layout. So you don't have to have a less than or a greater than. But the stepping through is how EQuIS finds out what the hardness is.
Allison, I don't know, does that answer your question? All right, thanks. Julio asks, is there any way to specify the number of significant digits being returned for the calculated advanced action level?
Yes, the ALE2 report has a whole section on significant figures. So the default is that it calculates the significant figures based on the number of significant figures in the action level. That works when you have that doesn't work well with the calculated, because the calculation returns numerous significant figures. But you can see that you can use calc result, and so it uses the number of significant figures in your result data. So that's a pretty handy way to go. But you can also just specify the exact number, 1 through 6, I think it is, And you can also combine that with my favorite, my favorite is 3 significant figures and display in scientific notation equals yes. But then that's because I was raised by the Texas Environmental Agency, which requires scientific notation in all their reports.
Let's see, Carl asks, what if I have 2 hardness results for my sample? A field result and a lab result. How can I specify which hardness result should be used in calculation? Can I filter it out in the underlying AR or ALE report through the use of an analyte group to only return hardness results for a given analytic method? Yes, that's definitely one way you can do it in terms of either analytic method, or if the hardness cast number differs. I don't sometimes field hard or something like that would be the cast number that I've seen folks use. But if there is not a differentiator that you can select in terms of your analytic method or something like that, it just takes whatever result it approaches first. Is that right, Jim?
That's correct. But you need, you can't really get the data into EQuIS without one or the other of those. Either you've got a different CAS-RN for your field hardness, or you have a different test, right? And so presumably you have a different analytic method. I guess it's not necessary. You could have 2 tests with the same analytic method, but the short answer is yes, it uses the first one it finds.
I know there has been some additional questions about how advanced action levels are applied, if you've got, initial and reanalysis and that kind of thing, and where that there is an open help desk ticket on that for future conversation, because I think Allison, you were interested in that as well. So we'll certainly be back to you with more information on that once we've got that. But with that, I guess I would like to just say thank you to everyone for attending today's office hour session. This is the last in the series, so next week we are going to totally switch gears entirely, and we are going to be talking about enterprise permissions. And I'm really excited how that one's going to turn out. It's more of like a workshop, how to work through troubleshooting enterprise permissions. If you have any questions related to this topic or any of the previous ones in the whole Advanced Action Level series, if you've got future topic suggestions, or if you'd like to sign up for other office hours, you can email us at officehours@earthsoft.com. Thanks so much, Jim, for being on hand and for helping me through setting up these sessions. And thank you so much, everyone, for attending the office hour. Hope to see you next week.
Thank you, Liz. Well done again.